Hi and welcome to another 6502 video, Hopper on 6502. This is another video from the 65 Arduino playlist, and this is the last video about that blink example. I think we've beaten it to death. This video is going to be about the code generation and the optimization. So the benefits of using this assembler is it does a lot of the optimizations that we would normally do ourselves. So let's turn the optimizer off and compile this. So we go to the assembler and we see all sorts of things that make us cringe if we're experienced 6502 programmers. For example, a jump subroutine followed by a return from subroutine. So this should be optimized to be just to jump to there and then use the return subroutine from the place you jump to. So that's an obvious optimization. Another one is all these jump statements here. So this is, inside the loop in this delay long, if 0 break. So it's like if equals 0 break. So if that's true, we jump out the loop. If not, we continue, and the continue means carry on past that, go to the end of the loop, now jump to the beginning of the loop. Whereas the jump out goes, where's the break? This one, the break out there, jumps out, jumps to there, and then jumps to the end. It's got two jumps, right? So this is the code that's automatically generated by the code generator. And it's pretty generic because it generates similar code for whether it's the MOS 6502 or the 65CO2S. It's the optimizer that decides how to optimize jumps. Anyway, we're going to look at jumps. We're going to look at, see if it deals with that. Also, we can see here at the end of the main programming block in Hopper, it's got a halt, which is actually an undocumented feature of the MOS CPU. It would use an STP instruction here if it was on 65CO2S, which is a documented way of stopping. It's just sort of a predictable way of exiting if you say, I'm actually going to run off the rails and exit the main program rather than run around in a loop. But in our program, it can never get there because we've got a loop that never exits. So this is unused, unreachable code. There's another form of unreachable code too, and I'll show you that in a second. Here again, we've got lots of jumps. So we've got a, branch if not overflow 3 forward, and then if it is overflow, jump to the end. So it's got two jumps to do an if statement. So let's go have a look at this and turn on the optimizer. So there's the optimizer, turn it on and build, and we'll build again. Oh, I'm in the wrong, I'm in the listing. It's trying to build a listing. Listings don't build so well. Okay, there we go, built. Another thing I want to show, I'm using this delay long. I'm not using delay short. That's another form of removing unused code or unreachable code. So you can include all your libraries and only use little bits of them, and your program will still optimally only include the bits that you actually used. And to do that, it needs to relocate things as well, obviously. So it really avoids using fixed addresses. So let's have a look at that. So if we look at our methods in here, we've got the delay long, but there's no delay short. There's no, it didn't use that. And if you recall, there were like 3 jumps in here. And the optimizer for this one, what it's done is it's flipped the condition. So even though I said if 0, it's flipped it to if not 0. And because what I'm really saying is continue the loop if it's not 0, and just fall through and exit if it is 0. So that continues the loop. So it's quite tight in terms of the optimization. And the other optimization I spoke of is a jump subroutine followed by a return from subroutine. It replaced it with a jump straight to the subroutine, and then you'll use that return from subroutine over there. There was a halt instruction at the end of the program. It's removed it because it's unreachable. It can't get there. So it gets rid of like no ops. Yeah, in fact, if you're trying to do something sneaky with no ops for timing, they'll get removed because they don't do anything. So the one thing I might want to do in future is turn the optimizer on and off optionally so that you can keep stuff like that in your code, because it'll just do you a favor and get rid of all your no ops. Talking of which, you can see define here as like a C syntax thing. There is it supports if-def and end-if and else-if and all that, so you can do C style optional assembly rather than the dot directives of a regular assembler. Anyway, it does more. That's sort of just scratching the surface of what the optimizer does. It does most of the obvious things you'd like to see, like the optimizing of branches, short branches and long branches, and it does that all automatically. But I think that's enough as an overview as to what are the benefits of using this tool over just sort of a, in quotes, dumb assembler that just assembles everything you give it. So you include your library and it just builds a whole library into your program, whether you used the methods or not. Yeah, I think that brings us to the end of picking this Blink example apart. I think I shall have to move on and create another example so we can start again. So thank you for watching, and I encourage you to take a look around the YouTube channel and see if there's any other playlists on the 6502 that you're interested in.